Mm. Mm. Okay. Look, anyone is here? Oh. Okay. Maybe let's wait a minute or two for others to join. There was no previous meeting. I guess that no one will show up on December 31st. So decided to just say it's cancelled. So I hope no one showed up. Hello.
Hi.
Happy New Year, even. It's a little bit late, but I don't think I was on any meetings, but yeah.
Yeah, thanks. Sometimes it's still February or March and you're still saying Happy New Year to some people.
What happens?
How was your break?
I didn't take a break.
Okay.
I mean, I
Like,
took 2 days off, like
hmm
during the Christmas break,
hmm
but just to do some preparation for the Christmas, but
I see.
didn't mm, yeah,
Yeah,
work most of it.
I also didn't have a break. Uh,
Mm.
but then so at my work, I had a lot of deliverables by end of year.
Mm.
So I've been trying to catch up. I think now I'm down to 33 pull requests that are, or action items that are missing from MedCD. So it went down from 150 or something like that.
Oh,
Anyway, eventually I'll catch up.
yeah, don't worry. Yeah, I think we can start. Oh, we have more people. That's great. Unfortunately, um, will Marcus will not be able to join today, but still we can go through the robustness test site fully. Yeah, so hello and welcome to the robustness test meeting. Today is January 14th, first meeting this year. So if you want to take opportunity and propose your own topic or ask any questions, feel free to do so. Calendar or meeting notes are connected to calendar. If you want to edit, or you should have edit rights if you're part of etcd dev Google group. So yeah, if there are no topics, I think we can just jump into triaging or reviewing ongoing issues in on GitHub first. So I've there was some or I opened a new issue here, and maybe yeah, there are two issues that I opened pretty recently. One, there is a consistent failure in antithesis around exit codes. I think antithesis hardly or expects that if you send a kill signal, it will process will exit with specific or term signal. It process will exit with specific status code. So to clean it up, I propose we are like looking and documenting all the status code that etcd is returning and trying to clean yeah, centralize it, make it obvious, and maybe we can trace why why we are not matching status code, and maybe at least we'll have a clear answer. If you're interested, there was a PR. We already documented all the status code that we expect, so now it's part of the official documentation. And yeah, we have signal termination and status code. So we are trying to like there is a lot of lines of code. We are trying to make it more obvious and clear and centralized in one place. Yeah, so that's just happening. There is a person working on a new contributor. At least I don't know. I haven't seen him contribute to robustness tests. The second thing, I think Henry and Nant started, or yeah, has been pushing through a couple of people, was around server information. So I think that was an older issue that I filed because or while debugging the linearization issue that we have. FYI, we still have we need to figure out how to fix it. Okay. Let me maybe paste both bugs into the notes if someone is interested in following along.
I thought the one that adds the server information is already done. The PR was merged, right?
Yes. So, I mean, if it's merged, maybe we could close it. I need to double check. I think I cut the scope of the thing because we have member ID now, so maybe that's good enough. So the second part. So okay, I think that's a good point. So the second part that we or here is the second part that that Henry started handling. Like the second part would be great to have this information visible in the
Occupying.
The porcupine visualization, because like currently we have a dump in JSON of all requests that happened, so we know we have the source of truth, but linearization failure would be visible on the visual or linearization failure would be visible on visualization, and then like mapping requests to there is no one unique identifier for a request, so finding them can be pretty like tricky, because if it's a put request, those have unique values, so you can find them easily. But if it's get requests, those are not unique, so you need to try to you need to find it or the request. But if you so we also added the call and return. It gets a little bit more complicated. I think someone is writing on the chat. Hello, do you want to speak up or ask question?
Oh, not really. I was just greeting. This is my first time here.
Okay, awesome. Yeah, so maybe, I mean, we can go back after, but yeah, we usually start the meeting. If you have any questions or you feel a little bit lost, feel free to jump in and ask questions. Like the meet, like as the in the notes, it's written. The goal of the meeting is learning together how to debug the linearization issue or of etcd, and possibly other project. I mean, and learning from that that could be transferred to other project. So yeah, going back to the issue, the problem is we don't have, if the request, the second thing that Henry is working on or send a PR is that if maybe that was merged already, if the request is not part of linear visualization or linearization, I think maybe that was merged. It will not be not show up. So maybe we could. Oh yeah. If have a request will have unique call return value. So when it starts, when it ends, but because this was before this PR, it was not in the visualization. We couldn't know when the like the requests that are not part of linearization. We didn't know when it started, when it finished. So we couldn't even like easily find matching get requests. So now this is like solved. So they're like still like two PRs by Henry to the Porcupine to improve the visualization and metadata. So whether it's closed, we can, or yeah, I think we can. Maybe I closed it too early. Because we would want to make sure that this information is not only stored in the dump of history, but also here. So let me maybe clarify the tasks. So here is the first PR, and here the Porcupine tasks. So we have done this, and we add metadata, improve metadata. Okay. Oh, so there are tests. Yeah. So here is the second. Um, so yeah, we have the metadata now. We should we have member ID in saved to the request report. We just want to it visible so we can. It's easier to debug linearization issues. So those are the two new things. Is there in under robustness labor? Is there any other issues someone wants to discuss?
Well, I'm not sure if that falls under robustness, but I had a new PR that asked the range test. I noticed that it has a flake on cast watch. I'm not sure that's a flake on like the latest PR that I have.
Yeah, I didn't fully. This is uncommon.
Oh,
So
that's fixed. That one is fixed. That comment. But if you come down to the checks, like that.
You mean
Yeah, yep, that one maybe.
that's just a verify check. So
Oh,
this is
okay.
verify is just simple lints plus validation that we enabled.
Yep. I mean, this morning I found before I made this change, there's some cast what that failed. I'm not sure we can see that now, but anyway, I can send you later.
No. Yeah, if you want, if you had, I mean, we have flakes in tests. We try to track their frequency, and if there are too many flakes, we will address it. But overall, like it's much better than before. Like I remember the times where we had like 50% of flakiness of the test suite. You can check it here. This is the best dashboard to debug the flakes because it's post submits. So the code that was merged, which means it at least passed the test once, and it's already on the master because it post submit. So you can check, like how often coverage fails. Oh, maybe this is sometimes test grid loads too much data and crashes the page. Yeah. Can jump here. Oh, yeah. So here, for example, you can check if there was a flake. There was no flakes on this here, but or here we have a failure even. That's interesting. I can guess when it started, but this is like example of a flake. End to end. I need to. Why does it? I need to follow up. Usually we have flakes in integration tests. So yeah, here is a flake. Here is a flake. As long as the flakes, like, I don't know, like if it's 5%, 10%, that's not horrible. At least base. I mean, but there were efforts that where I proposed to track flakiness and automatically file issues, or you can even file automatically issues from test grid and use it to track flakiness, and everyone will be supportive if you want to fix the flake. But like itself, the flake, if you have flake on your test, you can file an issue, but and hope that someone will pick it up, but they're not. Until we have very high, like it's totally blocking merging, we will not. And I don't think there will be a huge reaction. Any other questions to that?
Nope, that's all. Thanks.
Yeah. I mean, on the PR, I don't know if I had. We are getting out.
I just made a fix for that. I'll verify as well.
Yeah. Just on the PR, it's just over like note. There is a lot of things changing, and someone will need to verify during review that every scenario here has a matching case here, and that will slow down the review. I don't know if I suggested to split or how to, or I tried to suggest to split or design the changes in a way to minimize this diff, because it will be very slow and hard to review multiple. Like in the end result is maybe we add new tests, but we want to make sure that all the scenarios that were covered before are covered, and this is toilsome work.
So do you want me to split the test case into multiple PRs?
I mean, the goal is to make it as reviewable as possible. Sometimes on GitHub it requires a little bit more work.
Yeah, but the current PR, is it okay as is, or do you want me to even split it to be even smaller?
My suggestion would be avoid mixing refactor, like changing multiple things at once. So here you change how you set up the test. Here you change what do you test, and here you change what how like the or how you do assertions. So validating all of this at once is like exponentially more costly, because every time I read a test, I need to validate. I need to check if not only this scenario is present here, if this scenario is still validating things that were validated here, and how the new setup changes the thing. So I don't know if it's great most important thing to do, or if you have time to do it now, but if the changes were done, if you just changed this part, like if you refactored just this code to this code, this format, that would be merged within minutes. But if you send this 400 lines of code, it's an hour of code review.
I see. I'll find a way to make it easier. We can take that offline too.
Yeah, sure. Sounds good.
Thanks, Mari.
Yeah. Okay. Any other questions about the open issues? Okay. Maybe one thing I wanted to mention that happened during the Christmas time. I had some time to fix one flag that we had for a long time. Let me. Yeah. So here's the fix. Let me send it. So we had for a long time in antithesis testing, we had flags that said the pages. It said that the test failed because it couldn't load the request history, or not the request history, etcd wall, or whatever it's called here. And yeah, it's the page. I don't know what if they request. Yeah, loaded persisted request. So in the robustness test, we use persisted requests, which are the requests that are saved to in etcd on etcd wall, because we want to because it's an optimization that allows us to look, instead of trying to consider all possible cases when trying to find a correct path of code of request execution, we can which can be very costly, because some requests can reorder, some requests can fail, and we don't know whether they even like were processed or not. We look up on the disk of etcd what are the requests that were on that were really persisted, or at least noticed by etcd, and this like gives us a huge performance boost, which is needed to make linearization in sensible time, because it's a np hard problem, which like the exponential complexity is very costly. Like on the bad run, on a good run, linearization can take milliseconds or tens of milliseconds. On the bad run, it can take hours. It can take hours. So it's roll of the dice. So we use this the optimization to stabilize the complexity and lower the runtime. And there was a new type of failure, of watch failure. So I noticed that there was even though we only had like problems with loading request, I noticed there was a watch failure, and the watch failure was pretty unique because it basically said that there is a missing request, like here, like there is something we expected. We didn't expect requests or event to be in watch history. And after investigating it, it turned out our logic for reading the wall was also very incorrect. The reason, or incorrect, it was simplified. It was just modified logic that etcd uses to write wall, and it had the problem of fact that etcd assumes that it only makes sense to read the history from last wall entry, so or from last snapshot. So you can see that when you open previously, when we, this is like the code library that we use for opening wall in etcd server, and you can notice that we provide the snapshot. So usually etcd only reads from snapshot because yeah, I mean, it makes sense. You don't replay whole history if you have a snapshot in the middle. So, but for this exercise to know all the requests that were processed, we want to read from beginning. So we set index 0. And this was not working for a situation where the wall history was incomplete, which can happen if you have, or it didn't happen in robustness test, because in robustness test we only execute one failure during the test. So it means only one member will have a hole in their wall history, usually if you disconnect it from network. But on antithesis side, the platform is injecting all the bugs all the time. So this results in all the members having holes in their wall, and that made and that's why we never observed the issues with loading persistent requests on the robustness, but it's something that happened pretty frequently on the um, antithesis side. And like there were more failures than successes, and the reason is just the previous logic at least like failed, and when it failed or if there were too many holes in the wall, it just failed miserably and said I cannot like validate it correctly, because it would be worse to guess than validate. But with the fix here, which is a custom implementation of decoding the wall, and we managed to just read wall using instead of using wall, which is or library for reading wall like server, we use decoder, which is just decodes the wall entries, and we with some custom logic for handling uncommitted entries. This fixed the issue. So here like some tests. And thanks to that, we now have 0 failures in reading the wall, which is a pretty great result. So if we wait for antithesis to load, and we go to antithesis assertions, if the my laptop performance mode allows to open the page, we can see that loaded persistent requests succeed, and it consistently succeeds for since December. So that's a pretty great result that we went like immediately solved multiple issues in antithesis tests, or like how it reports. So now we are down to 8 issues. So we are slowly, like the ultimate goal would be to get antithesis, like if this is, it reports 8 ongoing issues, and in what was that, November we had 11, 10, 11, it would be to slowly burn it down to to lower number, to in best case 0. So that's why the invest or the proposal to handle exit codes, so that we can like remove the exit code failures, and in the end have purely green dashboard, which is pretty important if you want to have having no flakes and no random signals. It's pretty important to build trust, so people, when something fails, people will immediately look into that. Okay, so that's updates on the ongoing work and issues in or new issues in robustnesses. Are there any questions? Any yeah, any and anyone want So if you're interested in any of those issues, feel free to use the link for the or use the label robustness testing, which covers both things. So here's the list of all issues related to correctness testing or finding failures. So we still have and maybe I can mention quickly, we still haven't debugged one linearization failure that was detected long time ago, like some time ago. It's just good news is that I think Marcus is not able to attend today, but he said that he found an example how to look up at like process memory, or like look up take snapshot of without interrupting the execution. So to explain for anyone that was not here, the issue that we are tackling is the fact that we have linearization problem, and we were not able to like easily find what is causing it. And we are trying to use antithesis platform to give us like easier answers than like debugging it in naive way, because it only reproduces every second test, and the test takes 12 hours. So we could try to debug it using logging, but it would take, every iteration would take 24 hours, which is not great. So we are trying to use antithesis to debug things, and the result, unfortunately, from that is that in antithesis you can replay the execution of because it's deterministic platform. It allows you to replay the execution of the failure, like previous failures. The problem is to get information out of etcd, what is the internal state of memory. You need to connect profiler, and you can do that, but that interrupts the execution and results in etcd behaving differently, which and the linearization disappear, which is yeah, this can happen. Yeah, I like my guess. If I would guess, this is like some error or retry handling in read index confirmation. Like, so maybe but I don't want to, like, it's pretty hard to test or should, because this is like already part of the raft. So we original raft paper proposed this read index as an optimization, and that was not, and read index was not implemented in etcd version 2. It was added in version 3. So that's and my investigation like was around this area. So and I saw like some retries from logs. So my guess would be there. So maybe it's some timeout, it's some retry, it's 2 lines reverted. So yeah, what Josh suggested, that it will come down to 2 lines being in reverse order.
I just remember having to do like 96 hours of testing with Postgres once upon a time for a linearization problem that came down to literally 2 lines of C code that were out of order.
Yeah. I can understand that. I'm usually suspicious if someone wrote code in a way that you can reorder 2 lines, and even though if you did that, the program would break, because I know you modified the memory in different in incorrect order.
Yeah.
So
I mean, in this case, it was, in this case, it was modifying memory and then checking the spin lock instead of doing it in the opposite order. And it's one of those things where it's literally 2 adjacent lines of C, so two sequential commands to the processor, and you wouldn't think something could get in between them, but if you run enough concurrent stuff, something will get in between.
Yeah. We had exactly this like original V2 original linearization issue, or like race in version when we released 3.5. That was like basically 2 Go routines executing at the same time, which normally not even happens, because one Go routine was like executed once every couple of minutes or hours.
Okay.
So yeah, the race was amazing. But yeah, it was at least reproducible. You just needed to send like thousands of QPS at the same time, and those Go routine, like then you would make the hotspot in that area, and it happened. Okay, I think we can finish the reviewing ongoing issues and go to analyzing the test failures or flakes. We didn't do that for some time, so we can like at least check if everything is green. So here is the robustness dashboard, and there are some flakes, but I don't think there is a lot, fortunately, to look. I'm happy to see that we did some changes yesterday. Henry submitted some changes to robustness test, and they still pass, which is not always easy. So that's a good work there, because we have more flakes on S319X architecture. So we test multiple architecture, all the multiple stable branches. There are more flakes if you aggregate all of them. More. And robustness tests are a little bit more naive method of testing, but we still use it to confirm. So the main candidate, and I think what everyone will see mostly, is the QPS, which is exactly what happened here. In robustness tests, to make sure that the tests are able to find hotspots, or like based on QPS, we try to require the test to succeed to have some minimal QPS, and from time to time we burn enough CPU that maybe cloud providers are throttling us, or this is like my guess, or disk is starts throttling because we haven't got to running the job in a I would call it like guarantee with dedicated disk. We still I think depend on if I would need to double check, but yeah, we have some guesses why sometimes the throughput, but it happens usually pretty rare, or maybe a couple of times per run. So we have 2 cases, and I just try to for track count number of cases of the QPS. So that means instead of linking to test, maybe it's easier to say number. Yeah, we have 3. But looking at this case, example, for some reason, during one test, we couldn't even execute and successfully finish one request, which is pretty odd. We have 4 cases, and this is maybe something else. And this is nil pointer. Yay! Is it where? but this is nil pointer in end-to-end framework. So this is new. So we had 4 cases like this, and we have a new case. So I can link this. Yeah, it's not a bug in etcd, it's bug in testing framework. So we have sometimes even races in test framework. Yeah, looks like shutdown of etcd didn't go normal path, and somehow we ended up going through using memory that was already freed. I expect on the close. So we have, going forward, we have 6 cases for QPS, 7, 8. So even like we had 169 tests and only 1 flagged. So it's less than 1%. 9. I think I've saw 9 cases. So we could technically file an issue for this. Issue. Is it a flake? Is it a bug? It's some both. It's maybe pan to so I will just file it quickly. Anyone? There is no fields, so I can just paste this and to maybe can I add the label after? So there. So to track, let's add robustness. So if someone is interested in looking into that, it shouldn't be super hard. If you ever debug panics in Golang. Okay, so that's all robustness test failures. We can also take a look at the antithesis, which is a little bit less convenient. Maybe I can. It's a new dashboard, so I don't think we have obvious process how to go through them. Also, the dashboard here, every page is very, very heavy. Because for some reason, opening any row tries to load all the history of previous failures. So we have constant queries. We have still issue with that validator, which was added by previous maintainers. We just like run it, but I don't know why this. And here we have linearization timeout. So linearization timeout is exactly the case if linearization hit exponential time. Instead of we have a timeout of 5 minutes, and if it doesn't fit, we hit timeout. But we have also panic in etcd. So this is how antithesis recognize panic. So it expects no panic. I think it's easier to do that. Yeah, there's, I don't know how memory, or usually the problem with memory is that our memory is hit during linearization. It's not etcd memory, it's the test memory. So here, linearization. So we had just a linearization timeout, failure in assertion, but this is like never, this assertion never passed, and then panic. I think it's known panic, so I don't know if there is a worth to look at. It's the panic when there are two snapshots sent at the same time. So we, I don't know, get it. The report gets every couple of days or like a week. But we can look into linearization timeout in a second. Let me, yeah, here is another case. And we also have linearization timeouts. So linearization timeouts are still happening. But they're after nice some green for longer time, we are back to a lot of linearization timeouts. Another case. Here we just had exit code, which is already filed as an issue, so nothing interesting. Here we have memory usage, panic, and timeout. Don't really need to look at all the panics or the timeouts, but just collecting them in case one of them is not super useful. And here we have linearization. Oh, so why the linearization didn't show up? This is, so here it says it finds a linearization almost every day, or maybe it, who knows? Sometimes I don't understand the dashboard here. But if we open here, and so I opened a new thing with not reachability, always assertions, linearization passes. Oh, so we didn't have linearization failures for a long time, like 2 weeks. It's interesting, at least to say. I'm a little bit worried that this could be, maybe the previous linearization was not a linearization failure, but we did something else wrong. I'm not sure. We did, or usually when we confirm linearization, we confirm that patching of history doesn't affect the, or reading the persistent request doesn't affect the linearization, so there is no bug in linearization. So fact that we, after changing, I think I changed on 31st or December around here. So we still had, but I don't know why we stopped observing linearization failure. Okay, I think we can take a look into, robustness timeout if we still have 10 minutes. Are there any questions to what we discussed? What we just discussed, or I presented? Okay. Hopefully everything is clear. So let me now jump into how do we debug linearization, or at least timeouts. for linearization. First, I would want to share more of my screen. So can just share entire screen because I will be using my IDE. And sorry for so I don't see chat now, so let me know if someone writes. But yeah, starting. So we have linearization timeout. What does it mean? It means the cost of linearization was we got into exponential calculation of all possible combinations, and we can validate it by or this is somewhat results of both exponential time, but also limitation of hardware. Like we don't run super great hardware locally or in antithesis. So usually you should be able to run, maybe even on my laptop, semi-powerful laptop, you should be able to rerun the linearization and maybe finishes before 5 minutes. So you can do that by just, like I showed, accessing the dashboard here. So FYI, this dashboard is not public. It requires you to authorize to antithesis by GitHub. So you need to be etcd member. So you need to be at least somewhat contributing to etcd. There is no decision apart of that. They need some authorization of source. So we connected it to GitHub, but these links can be done by anyone. So if someone wants to follow, I pasted the link into the notes. So we have the linearization timeout, couple of cases like this, and here's the link. So we can take the file, as I showed. You can download the report, which is it's the directory that includes dump of everything that happened during the test, or at least on the client side and the etcd server. So if you look at here, there are like 16 clients now. We now have a lot of clients, and we have server. So each server name is not great, but yeah, here is server, like 3 members of etcd, and here is some dump of additional information from the. So each client, some clients didn't do anything, but for some clients we have watch operations and or operations which are key value and watch. For historical legacy reasons, we split it, and then you have linearization visualization. So we use Porcupine library, which is an open source project for Go linearizer to find the to try to find a path of execution between requests. So if you look at here, there is a black path, which is the path that we are we managed to get to by going one request by the other, and then there is red path, which is things that we couldn't go further or we couldn't connect to. So if the path is just based on the fact that each request has some start time and some end time, and then if a request and there is some model that says, oh, if you save a key, you should be able to read the key. And those requests need to be ordered, and then if the request one is after the other, then you cannot interleave them. So this request definitely needs to be before that. So yeah, this is what linearization algorithm does, and for visualization so like this. But this is reported as error, but this was a timeout, which means this is as far the linearization has come. But we can rerun the linearization. So in that etcd repository, under the tests and robustness, there is a test data directory, which is which is an empty directory, which in my case had some previous reports where I was debugging, where you can just throw the report that you have on your hand, dump it here, and then run a test from a project. So let me know if this is visible. But yeah, I can do make test robustness reports. Reports. Okay, so this will execute a unit test that will, or not a unit test, but a test that will try to load all the reports in the test data directory. And now it burns CPU on trying to linearize. So here is the timeout. We have just 5 minutes, so I don't know if we will go far, but usually what I will do is check if first it's good to know that if there was a timeout in antithesis platform, it's not a failure local on a stronger machine. So first it's useful to know that timeouts there, like any timeout that we hit in the on the platform, is not resolvable or to a failure. It's still a success. And second, I use those reports with timeout to possibly, it's a good thing to profile and optimize the code. So linearizer is technically doing generic operations, but there could be still optimized. And also, in the end, it depends on some library that we provide the model. And this model needs to do operations like comparison of state and other stuff. So we could try to optimize this. So we did a couple of optimization previously, things like optimizing comparison, because that's mostly what the linearization is. So I think we can, I don't know if this will finish today because I'm on my laptop. If I was on my workstation with Threadripper, that would be pretty much faster. Sometimes the difference could be huge, like running it locally could be like, it could time out in cloud on 5 minutes, but locally pass after like 5 seconds, because like the difference, it's single threads, single throughput of single thread, so it can local machine and like fast processor really matters here. So yeah, I think that's mostly it from me for today about debugging robustness tests. Are there any questions related to that? Okay. Does anyone want to wait until the meetings runs out or the linearization will pass, or we could just, I think, finish today? Or does anyone has any topics that we could do in the meantime? Okay. I will not bother anyone more, and we can stop talking. I think we can finish for today.
Cool. Thank you.
Okay. Thanks, Ivan. Okay.
See you.
See ya. Have a great
Thanks,
New
Mark.
Year. Yeah.
Bye, guys.